Right now, as you listen to this, an object from another star system is performing a maneuver behind the Sunday. It arrived at 30 miles per second. It passed Mars at a distance where high-resolution cameras could resolve surface features. And tomorrow, October 29th, 2025 at 11:44 Universal Time, it reaches perihelion while Earth sits on the opposite side of our star. The timing, to quote one Harvard astronomer, is optimal for an Oberth maneuver, for maximum efficiency trajectory modification. For deployment, we have 8 days to find out if physics is playing a trick on us or if we are the ones being played. Here's what we know, what we don't, and why the next 67 days might rewrite every assumption we've made about our place in the cosmos. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System telescope in Rio Hurtado, Chile, flagged an object designated A11PL3Z at 4.5 astronomical units from the Sunday. Within 48 hours, trajectory analysis confirmed what the designation now tells you: 3I/ATLAS, the third interstellar object ever detected passing through our solar system. The Minor Planet Center collected 122 observations from 31 observatories. Pre-discovery images extended detection back to May 21st from Zwicky Transient Facility and the Transiting Exoplanet Survey satellite. The object entered our system with an eccentricity of 6.14, not 1.2 like Oumuamua, not 1.001 like typical hyperbolic comets, but 6.14, a record-shattering value that tells you this thing is moving fast and it is not staying. Its inbound velocity, 44 kilometers per second. Oumuamua crossed at 26, Borisov at 32. 3I/ATLAS came in 68% faster than the first interstellar visitor and 40% faster than the second. Think of interstellar objects like messages in bottles drifting between islands. Oumuamua was a note scrawled on a scrap. Borisov was a postcard. 3I/ATLAS is a shipping container. Initial photometry at discovery distance suggested a diameter exceeding 20 kilometers if albedo matched typical asteroids. Let that sink in. 20 kilometers. The impactor that ended the Cretaceous was 10. Within days, astronomers calculated the odds. The total reservoir of interstellar asteroids, the number drifting through our galaxy available to randomly intersect our system, produces a detection probability for a 20-kilometer object over 5 survey years of 0.01%, 1 in 10,000. You would expect to find 100,000 Oumuamua scale objects before encountering one 3I/ATLAS scale object. We found 2 small ones. Then this, the Keck 2 telescope in Hawaii, Hubble Space Telescope, James Webb Space Telescope, the European Space Agency's Mars Express, ExoMars Trace Gas Orbiter, and NASA's Mars Reconnaissance Orbiter all turned their instruments on this visitor. Hubble imaged it July 21st at 277 million miles from Earth. It showed a teardrop-shaped coma of dust extending from the nucleus. It also showed something else, something Hubble principal investigator David Jewett at UCLA noted in the data release: a forward jet 10 times longer than wide, pointing toward the Sunday, not a tail blown back by solar wind, a jet aimed sunward, an anti-tail. Standard cometary geometry produces tails that point away from the sun due to radiation pressure. Projection effects can create the visual appearance of anti-tails for Earth-based observers when viewing angle aligns with the orbital plane, but this was not a projection effect. Multiple viewing angles, multiple instruments, same feature, a collimated jet of scattered sunlight extending forward from the nucleus. Spectroscopic analysis complicated the picture. Early observations detected no atomic or molecular gas signatures in the spectrum. Comets outgas. That is what comets do. Sunlight sublimates. Frozen volatiles, water, carbon dioxide, carbon monoxide, ammonia, and you see emission lines. 3I/ATLAS. at 4 astronomical units showed brightness consistent with a 20-kilometer object, but no gas. Then, as it approached 3 AU, Webb's near-infrared spectrograph captured faint signatures: carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice. Not 80% water like most comets. Estimates place water content near 4%. What makes up the other 96%? The Keck Observatory reported something that does not belong in cometary spectra: nickel. Not trace nickel. Not nickel contamination from the detector. Nickel-carbonyl, a compound formed when gaseous nickel combines with carbon monoxide. Nickel sublimes at 1455 degrees Celsius. Comet nuclei do not reach 1400 degrees. Comet Borisov, the previous interstellar comet, showed standard abundances. Nickel to cyanogen ratios in line with solar system comets. 3IATLAS exhibits nickel to cyanogen ratios, orders of magnitude higher, orders of magnitude. There is one place in the peer-reviewed literature where nickel-carbonyl formation occurs at scale: industrial nickel refinement, the Mond process, terrestrial metallurgy, not astrophysics. Here is where the skepticism must be absolute. Nickel in space exists. Nickel-rich asteroids exist. M-type asteroids in our own belt contain up to 90% iron-nickel alloy. But those are solid metal. They do not produce gaseous nickel unless heated to vaporization. So we have 3 hypotheses to test. First, the nucleus contains metallic nickel deposits that solar heating vaporizes and combines with outgassed carbon monoxide. Possible, but thermodynamically expensive. You need sustained temperatures above 1400 Celsius at depths where carbon monoxide sublimates at 200 Kelvin. Second, we are observing a collision product, debris from an interstellar impact that was flash heated and now retains thermal energy. Possible but improbable given the cooling timescales versus estimated travel duration. Third, there is a process occurring inside or on the surface of 3 IATLAS that we do not understand. A chemistry or physics that has no terrestrial or solar system analog. Possible, fascinating, and unsettling. The polarization data made it worse. When light scatters off particles, it becomes polarized. The degree and orientation depend on particle size, composition, and geometry. Comets produce positive polarization at most scattering angles because micron-scale dust grains scatter more light perpendicular to the incident direction. 3. IATLAS shows negative polarization at certain wavelengths and angles, unprecedented among comets, including Borisov. Negative polarization indicates either highly irregular particle shapes, refractive indices outside known cometary ranges, or coherent scattering effects that require particle organization. Think of it like this: if you shine light through fog, it scatters randomly. Positive polarization. If you shine light through a cloud of aligned needles, it scatters coherently. Negative polarization. What produces aligned particles in a cometary coma? Anomaly stack, current tally, size probability 1 in 10,000, forward sunward jet, 4% water content, nickel-carbonyl at industrial ratios, negative polarization. We are not done. Trajectory analysis revealed 3 IATLAS entered the ecliptic plane, the disk containing Earth, Mars, Venus, Jupiter, at an inclination of 5 degrees. Interstellar objects arrive from random galactic directions distributed isotropically across the celestial sphere. You expect inclinations scattered uniformly from 0 to 90 degrees, 5 degrees. Within the plane where all the targets are, Oumuamua entered at 20 degrees, Borisov at 44. The probability of random interstellar approach within 5 degrees of the ecliptic, roughly 8%, not impossible. But stacked on the size anomaly and the chemistry anomaly and the polarization anomaly, 8% becomes harder to dismiss. It passed Mars October 3rd. Mars Reconnaissance Orbiter carries HiRISE, the high-resolution imaging science experiment, a camera capable of resolving meter-scale features on the Martian surface from orbit. 3IATLAS, approached within 30 million kilometers of Mars, well within HiRISE's operational range for a 10-kilometer target. ESA's Mars Express, an ExoMars trace gas orbiter, also had line of sight using their high-resolution stereo cameras and spectrometers. The images, if acquired at full resolution, would resolve surface structure, rotation state, jet morphology, and potentially discriminate between natural nucleus morphology and geometric regularity. As of October 28th, those images have not been released. NASA's current government operations status complicates data pipelines, but the images exist. They are in the archive. The question is what they show. October 21st, 3IATLAS reached solar conjunction. From Earth's perspective, it moved directly behind the Sunday. October 29th, tomorrow it reaches perihelion at 1.356 astronomical units, 203 million kilometers, just inside Mars orbit. Then it crosses to the day side of the Sun and becomes observable again from Earth in early December. That 8-day window, conjunction to perihelion, represents the highest velocity point in the trajectory, the moment where gravitational potential energy converts to kinetic energy at maximum efficiency, the moment where any propulsive maneuver, any trajectory change, any deployment extracts maximum delta V for minimum energy expenditure, the Oberth effect. If you wanted to alter course or release secondary payloads, you do it at perihelion. If you wanted to do it hidden from Earth observation, you do it behind the Sunday. Let me be explicit. The null hypothesis, the default assumption, is that 3IATLAS is a natural cometary nucleus with unusual but not impossible composition and trajectory. Unusual does not mean artificial. Improbable does not mean designed. We have a sample size of 3 interstellar objects. Statistical inferences from 3 data points are weak. Natural processes we do not fully understand are more plausible than technological artifacts. This is the correct scientific stance. This is the stance the data currently supports. But the correct scientific stance also requires that when observations depart significantly from predictions, we expand the hypothesis space. Hypothesis 1. Natural comet with exotic composition. 3IATLA. S formed in a stellar environment with high nickel abundance, possibly near a supernova remnant or in a metal-rich protoplanetary disk. Its low water content reflects formation beyond typical snow lines, where carbon dioxide and carbon monoxide dominate volatile budgets. The forward jet results from asymmetric outgassing from a single active region on the sunward hemisphere, a known phenomenon in solar system comets. The negative polarization arises from fractal dust particles or glassy silicates. The ecliptic alignment is coincidence. 8% probability is not 0%. The size is unusual but not forbidden. We detected it because survey sensitivity improved. Vera Rubin Observatory just came online in 2025 and immediately found 2,104 asteroids in 10 hours. Detection rates are exploding. We are entering the era where large interstellar objects become visible. Verdict: plausible, consistent with known physics, makes minimal assumptions. Hypothesis 2. Fragment of a catastrophic interstellar collision. 3IATLAS is ejecta from a planetary disruption event in another star system, a collision between a metal-rich protoplanet and a volatile-rich body. The impact flash-heated nickel-bearing minerals, creating a transient high-temperature environment that infused the debris with gaseous nickel, which then froze into metastable compounds during the cooling phase. The fragment traveled for millions of years, retaining trace thermal energy and unusual chemistry. Its trajectory toward the ecliptic reflects the original orbital geometry of its parent system. Verdict: speculative but not impossible. Requires specific initial conditions. Explains chemistry. Does not explain negative polarization or timing. Hypothesis 3. We are observing technology. 3IATLAS is a probe. an interstellar spacecraft utilizing the Sun for a gravity assist or reconnaissance flyby. The nickel signature comes from industrial alloys in structural components or propulsion systems. The low water content reflects intentional shielding or fuel composition. The forward jet is active venting or course correction. The negative polarization results from metallic surfaces or regular geometric features. The ecliptic approach is deliberate targeting. The size is consistent with a multi-ton interstellar vessel. The perihelion timing optimizes energy efficiency for any subsequent maneuver while occulting observation from the civilization most likely to detect it. Verdict: extraordinary claim requiring extraordinary evidence. Currently lacks definitive signature. Cannot be excluded based on available data. The distance between hypothesis 2 and hypothesis 3 is vast. The distance between hypothesis 1 and hypothesis 2 is smaller. The problem is that hypothesis 1 requires stacking multiple low probability events. Size, chemistry, polarization, trajectory, all simultaneously. Individually, each is unlikely but possible. Together, they form a joint probability that shrinks rapidly. This is the improbability stack. Not proof, not confirmation, but sufficient to justify continued observation and open consideration. Here is the timeline. October 29th, tomorrow, perihelion passage, peak velocity, optimal Oberth maneuver window. November 3rd, 3IATLAS, passes Venus at 0.65 astronomical units, 97 million kilometers. December 19th, it reaches 1.8, 3 astronomical units from Earth, 274 million kilometers, and becomes observable again from ground-based telescopes. March 16th, 2026, it passes Jupiter at 0.31 astronomical units, 46 million kilometers, well within Juno's observational range. ESA's Jupiter Icy Moons Explorer, currently using its high-gain antenna as a heat shield near the Sun, plans observations in November using multiple instruments, cameras, spectrometers, particle sensors. Coordination with NASA's Europa Clipper is under consideration for twin ultraviolet spectrograph observations. Data return expected February 2026 due to current spacecraft orientation and distance. What are we looking for? Trajectory deviation post-perihelion. Natural objects follow ballistic paths determined by gravity and radiation pressure. Propulsive maneuvers produce measurable delta V. Astrometric observations in December 2025 and January 2026 will constrain position to sub-arc-second precision. Any departure from predicted ephemeris flags, non-gravitational acceleration, secondary object deployment. If 3IATLAS releases probes, those objects will have independent trajectories distinguishable in sky surveys. Vera Rubin Observatory, now operational, scans the entire visible sky every few nights. New objects with velocities inconsistent with main belt or Kuiper belt membership will stand out. Spectroscopic changes. If surface composition evolves post-perihelion, if nickel signatures strengthen or disappear, if new emission lines appear, that tells you something about internal state. Hubble's scheduled ultraviolet spectroscopy in November targets sulfur to oxygen ratios, a diagnostic for volatile chemistry. Webb's December observations after perihelion will compare pre- and post-flyby spectra. Rotation state. Tumbling objects exhibit periodic brightness variations. Stable rotation suggests structural rigidity. Oumuamua showed a 7.3-hour rotation period with brightness variation factor of 10, implying extreme elongation or tumbling. Borisov rotated but showed stable cometary activity. 3IATLAS rotation data remains inconclusive. High-resolution imaging from Mars orbiters would resolve this. If it does not tumble, if it maintains fixed orientation, that is anomalous for a natural body subjected to asymmetric outgassing torques. Polarization, evolution. Negative polarization is the signature that does not fit. monitoring how polarization changes with solar distance tests, whether the effect is geometric, compositional, or something else. If polarization flips to positive, hypothesis 1 strengthens. If it remains negative or intensifies, we are outside standard cometry phenomenology. Communication signatures, this is the speculative frontier. Targeted radio observations, optical SETI, laser searches. The Breakthrough Listen project has access to the Green Bank Telescope and Parkes Observatory. To date, no confirmed signals from 3 IAT-LAS, but there is a coincidence worth noting. The object's arrival direction, traced back through galactic rotation, falls within 9 degrees of the 1977 WOW signal bearing. That signal, detected by the Big Ear radio telescope at 71-hour 15-minute narrowband intensity, came from the constellation Sagittarius, lasted 72 seconds, and was never repeated. 3 IAT-LAS originated from a trajectory that, when corrected for stellar motion over the past 48 years, aligns within 9 degrees. 9 degrees at interstellar distances is millions of light years of angular separation, so correlation is weak, possibly meaningless. But it exists. The Loeb scale, a proposed metric for quantifying anomalous observations, ranks 3 IAT-LAS at level 4 out of 10. Level 0 is fully explained by standard astrophysics. Level 10 is confirmed technological artifact. Level 4 is multiple anomalies inconsistent with standard models, insufficient evidence for artificiality, warrants intensive follow-up. For comparison, Oumuamua peaked at level 3 before the hydrogen iceberg model gained acceptance. The scale is subjective, not peer-reviewed protocol, but it provides heuristic framing. 3 IATL. AS sits in the zone where scientific curiosity transforms into scientific obligation. What happens if 3 IATLAS performs an Oberth maneuver? If trajectory analysis in December reveals delta V inconsistent with radiation pressure and outgassing, protocols exist. The International Academy of Astronautics SETI Permanent Committee maintains post-detection guidelines. First, verification through independent observatories. Second, analysis to eliminate instrumental error and natural explanations. Third, if non-natural origin is confirmed, notification to the United Nations Secretary-General and public disclosure. Fourth, no response without international consultation. The framework is clear. The implementation, when faced with an object already in our solar system and potentially maneuvering, becomes complicated. You cannot negotiate with an object moving at 44 kilometers per second that has already entered your neighborhood. You can only watch, measure, and hope your assumptions about intent are correct. 3 scenarios for what 3 IATLAS might be if it is not a comet. Scenario 1. Autonomous probe on a mapping mission. No crew, minimal intelligence, programmed to perform gravity assists around stars. Collect data, transmit back to origin, or continue to next system. Purpose is benign, exploratory, scientific. Our solar system is one waypoint among thousands. The probe does not care about us. It cares about the sun's gravitational potential and spectral data. Implication: no threat, enormous opportunity for observation, possible data intercept if it transmits. Scenario 2. Beacon or warning. 3 IATLAS is a marker, a signal to civilizations that reach certain technological thresholds. Its anomalous properties are intentional, designed to attract attention from species capable of detecting interstellar objects and analyzing spectroscopy. The nickel signature is a flag, chemical impossible naturally, therefore conclusive proof of origin. The message is in the composition. Decode the ratios, understand the geometry, learn the language. Implication: first contact scenario. Requires decryption effort, possible existential information encoded. Scenario 3. Diagnostic or test. The object is assessing our detection capabilities and response protocols. It presents anomalies incrementally, observing how we react. Do we dismiss the data? Do we classify it? Do we publish? Do we collaborate internationally or fragment into competitive analysis? The trajectory through the ecliptic, the Mars flyby, the perihelion timing, all are designed to probe defensive readiness, scientific infrastructure, societal coherence. Implication: we are being evaluated. The assessment may determine subsequent contact strategy or threat classification. These scenarios are speculative. They are not predictions. They are hypotheses, space exploration, necessary for preparedness, but not evidence of reality. The current evidence supports natural origin. The current evidence also contains enough anomalies that dismissing non-natural hypotheses without completing the observation program would be premature closure. Science does not operate by ruling out the uncomfortable. Science operates by testing predictions. Natural comet predicts ballistic trajectory, post-perihelion, standard spectroscopy in December, conventional dust morphology, eventual fade as it exits the system. Artificial object predicts potential trajectory deviation, possible secondary deployments, anomalous spectroscopy, behavior inconsistent with passive response to solar forcing. We have the instruments to discriminate. We have the timeline. We have the opportunity to demonstrate that when faced with ambiguous data, humanity can follow evidence rather than assumption. December arrives in 67 days. By then, 3 IAT LAS will have rounded the Sun, crossed back into Earth's observational hemisphere, and begun its outbound journey. The high-rise images, if they are released, will show surface detail. The Hubble ultraviolet spectra will constrain volatile ratios. The Webb infrared data will map thermal emission. The Juno and JUICE observations in 2026 will provide final characterization as the object exits toward Jupiter and beyond. Each data point narrows the hypothesis space. Each measurement either strengthens the natural explanation or deepens the anomaly. This is how science works. Not by declaring certainty prematurely, not by dismissing signals because they are uncomfortable, by accumulating observations until the uncertainty collapses. If you want to stay on the timeline as this unfolds, as new data drops, as the December observations come in, as the Mars images surface, subscribing ensures you do not miss the signal when the pattern emerges. Because the pattern will emerge. Either we will look back at 3 IAT-LAS as an unusually metal-rich comet that taught us about exotic interstellar chemistry, or we will look back at October 2025 as the month we missed the obvious, because we wanted it to be natural. If it's natural, the science is extraordinary. If it's not, the implications are everything. Are we alone? That question has defined human inquiry for millennia. We have searched the skies, built radio telescopes, sent messages, listened for replies. We assumed contact would be electromagnetic, a signal at 21 centimeters, a modulated laser, a repeating beacon. We assumed they would want to be found. We assumed they would announce themselves clearly, unambiguously, in ways we could not mistake. 3IA TLAS suggests a different model. What if contact is not a message but an object? What if first contact is not communication but observation? What if they do not announce themselves because they want to see what we do when we encounter something that does not fit? The hypothesis is testable. The timeline is set. The instruments are ready. Tomorrow, October 29th, perihelion. December, reappearance and observation window. March 2026, Jupiter flyby and final characterization. 67 days to the first checkpoint, 138 days to final data. This is not speculation. This is schedule. The question is not whether we will have answers. The question is whether we will accept them. Will we follow the data or follow comfort? Will we expand the hypothesis space or contract it? Will we treat negative polarization and nickel-carbonyl and ecliptic alignment and Oberth timing as a stack of coincidences or as a pattern that demands explanation? Science does not promise comfort. Science promises truth. Right now, the truth is that we do not know what 3IATLAS is. We have 8 documented anomalies. We have 67 days until we can test whether those anomalies resolve or amplify. We have the instruments, the protocols, and the timeline. What we do not have is certainty. And that, more than any chemical signature, any trajectory analysis, any polarization curve, is what makes this moment important. Because the willingness to sustain uncertainty long enough to gather sufficient data is the only pathway to discovering things that challenge what we thought we knew. So, here is the question you answer by watching what happens next. Is 3IATLAS a comet teaching us about metal, enriched interstellar material, or is it a probe teaching us that the galaxy is not empty? Leave your answer in the comments. Natural objects showing us exotic but explicable physics, or artificial objects showing us we were never alone? The data will decide. The timeline is running. The object is behind the Sunday, and in 67 days, we will know more than we do right now. The question is whether we are ready for the answer. Right now, as you finish listening, 3IATLAS is at perihelion, hidden, moving faster than any object we have ever tracked from another star system, carrying chemistry that does not belong, exhibiting polarization that has no precedent, approaching planets rather than missing them, and doing all of this during a window that optimizes energy efficiency while minimizing observation. Tomorrow, it begins its exit trajectory. December, we see it again. The universe is about to tell us something. The only question is whether we will listen or whether we will explain it away before the data is complete. 67 days. That is all we have to wait. And all we have to decide is whether we are willing to sit with not knowing long enough to find out.